Alright, algebra, powers and exponents. Now this might be a two-part video, but I'm going to try to get it one video. If it is a two-part video, I'll let you know at the end of the video. So we're doing powers and exponents. It should be a review, so let's go on. Definition of power is an expression written with an exponent and a base. You already know what a power is. Let me show you an example. 2 to the third power. What that's saying is 2 times 2 times 2, which is 8. Now, this is the base, and this is the exponent. That's really important you know that. When I say this has a base of 2, this is what I'm talking about. The exponent's 3, this is what I'm talking about. Alright, so here's some ones that you probably already know. Some examples. This basically means 3. This one means 3 times 3. And this one means 3 times 3 times 3. 3 times 3 times 3 times 3. Now when you just have 3 by itself, it equals 3. 3 times 3 is 9, 27, and 81. Now you see what's happening. There's a pattern here. If I multiply this answer by 3, I get 9. If I multiply 9 by 3, I get 27. If I multiply 27 by 3, I get 81. So every time that we add a power, we're multiplying by one more 3. See? Multiplying by one more. Multiplying by one more. Multiplying by one more. It's an important pattern, pretty simple pattern that you need to look for. It's really important in this next slide. I'm going to go write down the ones that we previously had. Right here, 3 times 3 times 3 is 27. 3 times 3, which is 9. And 3, which is 3. Alright. Now, you notice how last slide I went like this and I said we're multiplying by 3 each time? So if I went in reverse, I would be what? Dividing by 3 each time. So I'm going to divide by 3. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. And if you remember from last year, me talking about anything to the 0 power is always 1. Even if it's 1,002 to the 0 power, that's 1. Anything to the power of 0 is 1. Remember that. Now let's keep on going. You see how these are negative exponents. They still work the same. I'm dividing by 3 every time I go up. So I'm going to divide by 3 again. 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. You kind of see a pattern there. This really equals 1 over 3 to the 1 power, which is 1/3. And this really equals 1 over 3 squared, which is 1/9. And it'll keep going. The next one's 1/27th, 1/81st, and it'll just keep on going. So these negatives basically mean it turns into a fraction. It goes on the opposite side of the division bar. You're dividing by 3 again and again and again. Alright? Now next, our square roots. So you get it? Square roots. Get it? Get it? Alright, so we're doing square roots. A square root is a number multiplied by itself to form a product. You already know what a square root is. We talked about it when we did Pythagorean theorem. Pythagorean theorem. So, I'm going to explain it one more time. A square is defined by its sides, because we know on a square all the sides are equal. That's the thing that separates it from a rectangle. All these sides are equal. So let's say they're all 3. Another thing that defines a square is that these have to be right angles. But the main thing is that all the sides are equal. So, when I say, what is the square root? What I'm really asking is, what is the side of a square? What is the root of a square? What defines a square? It's the side. So if I say, what is the square root of 9? What that's really asking is, what is a side? What are the sides of a square whose area is 9? 3. Because 3 times 3 is 9. So it's asking you, what are the sides of the square that has an area of 9? Perfect squares. Perfect squares are the ones we like. They're the ones we know. They're easy. They're a whole number whose positive square root, or a number, I'm sorry, whose positive square root is a whole number. So in other words, the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Those are all whole numbers. So they're perfect squares. They're perfect. Now here's the other side of that, which is not an example. Not an example would be something that would give you a decimal in return. So something that would be in between